Hello grade 10, this is Miss Hughes.
And this is Miss O'D.
And today we're going to talk about bearings. Let's get a general idea about what a bearing is. Oops, on the first page. So, suppose this is a big map. And you are standing here and you want to travel to this point here. We would generally say that you travel north, and you're probably used to that. If you're going this direction, you'd be going east. If you're going there, south and west.
What would happen if you're not going exactly north, south, east or west, Miss Hughes?
Let's say, for example, that you want to go over here. You might say that you're going northeast. But you can see it's not very precise, and that's where our bearings come in, the definition of a bearing. So here's the definition of a bearing. It's the clockwise angle. Make sure you write this down. Clockwise angle from north.
That's very important. So you should always draw a north line in from the starting point in every question.
Yeah, so if this is my starting point and this is the north line. Let's say I want to travel over here. I want to travel in this direction. Then I would measure the clockwise angle from north, and that would be my bearing. In this example, it would be, let's say, 90, maybe 110 degrees.
Yeah, that's a good estimate.
All right, okay, so let's try a problem involving bearings. Oops. Right, an aircraft flew 10 kilometers south and then 6 kilometers west. Good idea always to start by just drawing the picture. So there's my aircraft, and it's going to go 10 kilometers south and then 6 kilometers west. So that is right, yeah?
Yes.
Okay. All right, and it says, what is the bearing from its starting point? The word from is really crucial in this problem.
Definitely.
So you're going from here to here. And the word from tells me where to draw the north line. Okay, Mr. D, do you want to do the next bit?
Sure. So we always are looking at where we turn from north. So we start at our north line. We're facing north. It's like we're standing there facing north. We have to turn clockwise because bearings are always measured in the clockwise until we get to the blue line, because that's our path that takes us directly to where we now are. So where the green arrow is, that's the angle we're trying to find. Now, we can find parts of that angle already because we know about what we know about north, south, east and west. So we know that already part of it is 180 degrees, that bit on the outside. But then we have that little extra bit between the red and the blue line there, and we don't know how much that is. We don't know that angle. So now we might need to have to use some trigonometry, I think, to find that angle.
Yeah, luckily we've got a right angle triangle, so let's try and use some trigonometry. Now, in that case, it's often a good idea to just isolate the triangle that you're looking at. Oops,
good idea.
Not a very right angle triangle. There we go. We know that this is 10, we know that this is 6. And we're trying to find this angle here, let's call it x. So don't skip any steps, remember. So start with labeling the sides, hypotenuse, opposite, adjacent. I'm not interested in the hypotenuse, so we're going to use tan.
Very good, yes.
So tan x equals the opposite. Do you always write the formula first?
Always right, yep.
Yeah, me
so
too.
Set it up.
Opposite over adjacent. And then we'll do some substitution. So tan x equals, the opposite is 6, the adjacent is 10.
Now we have to find an angle. What's that extra step we have to take, Miss Hughes, when we have to find an angle with trigonometry?
Well, we have to get rid of the tan, we have to undo tan, do the opposite of tan, so that's inverse tan.
Good.
There we go.
Don't forget the inverse tan, that is written above the tan button in blue. So that means you have to do second tan when you put it into your calculator.
Yep. I'm just going to check that we're on the right mode.
Oh,
no, see.
Lucky you checked.
We did this last time. We need to be in degrees. Okay.
And remember, you know if you're not on the right mode because you'll normally get weird sorts of answers that don't really make sense.
doesn't make sense.
Maybe it's still on radians.
Didn't press
See?
enter.
We knew it didn't make sense
Classic.
because of the radians. So
Okay, let's try now.
not likely that it would have been an angle of 0.5.
Second tan, 6 over 10, which is 0.6. You could
Of course.
that as well.
Yes.
There we go, that's more
That
reasonable.
looks better.
So, x equals 30.963 ... So let's say roughly 31.
And don't forget then, because we're finding the bearing, we want to find the whole angle that we're turning from north. Remember, we're actually finding that green angle. So don't forget to add the 180 now. And so we get 211 degrees.
And that's our answer. Usually we have to give 3 digits for our bearings, right?
Yes.
That's the convention. So if you did end up with an answer that, let's say, was 27 degrees, you would put a 0 to ensure that you're giving 3 digits. Okay, next problem.
Okay. Okay, so let's continue with another problem. This one's actually a little bit easier than the last one because we don't have to even use any trigonometry. So here we have that Pattaya is on a bearing of 154 degrees from Bangkok. So that means if we're in Bangkok and we are facing north, we have to turn 154 degrees. For example, if we're in our plane, we need to turn 154 degrees to fly directly to Pattaya, as shown in the diagram here. And now it asks us to find the other way. So find the Bangkok's bearing from Pattaya. So we're now standing, we're in Pattaya, we want to go back to Bangkok. So we need to always start by facing north, and we need to see how much we have to turn in a clockwise direction to go back to Bangkok. So as indicated by the green angle here.
Okay, so we need to think back to grade 6 and some of our angle
Miss
properties.
Hughes.
Right, I'm going to extend this line. I think that might be a little bit helpful. So we can see some angles are the same. We can actually see that this one is the same as this angle here. What was the name of that rule?
I think they're called corresponding angles.
Yes, they are corresponding angles, so they are the same.
And how do we know that they're corresponding? What's the letter that they make?
Oh, they make an F.
Yeah.
Yes, that's right. So like a sideways F in this case.
Yeah.
Those two. Good. Okay, so that helps us now find the bearing because we've got 154 and we can see that this is 180. So we just need to do some addition. (234 degrees is our answer. That's our bearing. Was there maybe another way we could have found that angle?
Yeah, I think there's maybe some other angle properties we could use from way back when. What about the co-interior angles there?
Okay, so for example, this angle and this one, they are co-interior, so they add up to 180, which means this one would be 26 degrees.
Yep.
And then those two angles are on a straight line, so that would help us find 154.
Yeah.
too.
Or you could do, because we want to turn all the way around is 360 degrees. So we could do 360 minus 26.
Yep,
And that gives us what's left, the green angle there.
absolutely. Yep. We've also got alternate angles if you wanted to extend this line, so those two are the same. Lots of different options. Okay, next question. A little bit harder. So a ship sets sail from a port P and sails east, and then it's going to go south. So let's get the picture ready. This is
So we're at
let's
P.
start in blue. So this is P. It sails east. This is east, right?
Yep, for 16 kilometers.
16 kilometers.
And that's at Q now.
Q.
And then
And then
it sails south for 13.5, and that's at R, yeah.
all right, and then what's the question? It then heads from R back to P. So we're going to go from here to here. And they want to know what is the bearing from R. So again, the word from,
Very
that
important.
tells you what north line, excuse me, what north line to draw. So let's draw the north line here. Okay.
And can you just draw the angle that we need to find, Miss Hughes?
We're trying to find this bearing here. That clockwise
because
angle.
it's clockwise.
Yeah, what angle should we find first, maybe?
So we could split that angle if we sort of continue down north line down. So we could do a number of things, couldn't we? It depends on which angle properties you like. I would probably find the angle in the triangle there.
Yeah, I think that's going to be helpful.
I think whatever angle property you use, that angle will probably be useful.
Yep, and I think we can just use normal basic right angle trig.
Yeah.
So let's label our sides. Hypotenuse, and this is the opposite, and this is the adjacent. We're not interested in this side because it's not labeled, so let's use those two. So tan x,
Yep.
x equals opposite over adjacent. So tan x equals 16 over 13.5, and again, just like before, x equals inverse tan 16 over 13.5. So let's go over here.
Don't forget that second button before the tan.
16 13.5. Okay, so we get, oops, no, sorry, 49.844 dot dot dot. So roughly 49.8.
Yeah. So that's just the angle inside the triangle. We actually don't need that part of the angle because we're looking at the outside green angle for the bearing. In this case, I would probably do, because I know all the way around in a circle is 360 degrees, I would probably then do 360 degrees minus 49.8, because that should give me the leftover, which is the green angle
Yep.
there.
And if you want to be really lazy, you could just type in 360, subtract our previous answer.
And of course they would write that on their page though,
Yes,
as they're working out.
correct.
Like you
Like
have,
we've
Miss
got it
Hughes.
here. I'm very disciplined. Right, 310.155, running out of space. So the answer is 310.2.
Yeah,
Say to
degrees.
one decimal place. And that's bearings.
Good luck.